Assalamualaikum and hi everyone. Today my group will be presenting about pre-stress losses. My name is Siti NAJIHA. My group mates are NURUL FARHANA, NURUL ADILLA, Amirah and NURUL NATASHA. In pre-stress concrete, high-strength steel tendons are used to apply a compressive force to the concrete, which helps it resist tension and cracking. However, the pre-stressing force does not remain constant. It gradually reduces during or after construction. This reduction is known as pre-stress loss, and it can affect the strength, deflection, and serviceability of a structure. These losses are divided into two categories. First, immediate losses, which occur during or right after pre-stressing, and second is time-dependent losses, which occurs gradually over time. I'll be explaining one of the immediate pre-stress losses, which is elastic shortening. Elastic shortening occurs when the pre-stressing force is transferred to the concrete. At that moment, the concrete is compressed and shortened elastically. Because the steel tendons are bonded to the concrete, they also shorten by the same amount, which causes a loss of pre-stress in the steel. This loss mainly depends on the modular ratio, which is the ratio of the modulus of elasticity of steel to the modulus of elasticity of concrete, and on the average stress in the concrete at the level of the steel. So when does it happen? It happens in pre-tension members. The full loss occurs immediately at the time of transfer, when the tendons are released and the pre-stress is applied to the concrete. In post-tension members, the effect only applies to the previous tension cables. Normally, it is adequate to assume about 50% of the pre-tension loss for post-tension members. These are the formula for pre-tension and post-tension. To reduce this effect, engineers can stress all tendons simultaneously, use symmetrical tendons layouts, and account for the loss during the design process.
Next, I will present to you about the friction loss under the immediate losses. So friction loss occurs when the pre-stressing force decreases as the steel tendon slides inside its duct during tensioning. This happens because of the resistance between the tendon and the duct wall. There are two main causes: intentional curvature, which is part of the tendon's design profile, and unintentional curvature or wobble, caused by slight misalignment or roughness in the duct. Both create friction that reduce the pre-stress as we move away from the checking end. So this is the formula of the friction losses. And the main impact of friction losses is that the pre-stress force is not uniform. It's higher near the jacking end and lower at the far end. If not accounted for, this can reduce structural efficiency or even lead to cracking. To minimize friction losses, we can use smooth or lubricated ducts to ensure proper alignment during construction, or sometimes apply tension from both ends. So in short, friction losses are small but critical. Controlling them ensures that the design pre-stress is effectively achieved throughout the member.
Anchorage slip is when the pre-stressing force is transferred from the jack to the anchorage. The wires or wedges slips a little, causing a small loss of tension in the cable. Causes is due to slips of wedges during transfer of force from jack to anchorage, movement of anchorage block before it fully sits on concrete, and high stress in the wires of cables during transfer. Effects of anchorage slip is reduction of effective pre-stress force in tendons, greater percentage loss for shorter members, and possible increase in deflection or reduced crack control in concrete members. So this is how we apply the control measures. By using anchorage system with minimal draw-in as verified by manufacturer data or tests, ensuring proper seating of wedges and anchorage before release. Lastly, regular inspection and maintenance of stressing equipment to minimize mechanical play. This is the formula. Prestressing force in the cable over with the cross-sectional area of the cable equal to modulus of elasticity of steel times with slip of anchorage over the length of cable. Time-dependent losses. Creep. Creep happens when concrete slowly deforms or stretches over time over a constant load, which causes a gradual reduction in pre-stress in the tendons. What is the causes? Sustained compressive stress in concrete due to the pre-stressing, poor curing or excessive cement content, low concrete strength or high water-cement ratio, high temperature and low relative humidity. The effects of creep is long-term reduction in pre-stress in steel tendons, increased deflection of members over time, possible cracking or loss of serviceability if not properly designed for. This is how we apply the control measures. Use high-strength, low water-cement ratio concrete. Ensure adequate curing to reduce early shrinkage and creep. Also, apply pre-stress after sufficient concrete maturity, which older concrete creeps less. The formula is stress in the concrete at level of steel. Creep is equal to final pressure over area times with 1 plus the eccentricity square times area and over the inertia.
Shrinkage and relaxation losses are two significant types of pre-stress losses in pre-stressed concrete. Shrinkage losses occur as the concrete volume reduces over time, mainly due to drying after curing. This shrinkage shortens the concrete member and consequently reduces the tension in the pre-stressing steel. The loss of pre-stress due to shrinkage is calculated by multiplying total residual shrinkage strain by the modulus of elasticity of steel. The shrinkage loss depends on factors like humidity, curing methods, concrete composition, and age at transfer the pre-stress. Relaxation losses occur due to the decrease in stress within the pre-stressing steel and the sustained strain over the time. The steel tendons gradually lose stress after being tensioned. Relaxation loss is usually given as a percentage reduction of initial pre-stress and is influenced by the initial stress level, type of steel, and temperature. Relaxation becomes larger with higher initial stress levels. Together with creep of concrete and other losses, shrinkage and relaxation form the majority of time-dependent pre-stress losses. Total losses typically range around 15 to 20% of the initial pre-stress force, depending on whether the system is pre-tension or post-tension.